Part A asks us to show that sine x plus cosine x squared equals to 1 plus sine 2x. Let's first expand the parentheses on the left side by squaring this expression. That would be sine x squared plus 2 sine x cosine x plus cosine squared x. I will rearrange this expression so that the sine and a cosine x are together. And in that way we can see that it resembles the Pythagorean identity in the formula booklet on page 7. So we can replace the sine squared x and cosine squared x with 1, and the 2 sine x cosine x will actually be sine 2x. So in this way we have proved that the left-hand side equals to the right-hand side. Part B asks us to show that secant 2x plus tan 2x equals cosine x plus sine x over cosine x minus sine x. We can first rewrite the left-hand side as 1 over cosine 2x, and tan will be sine 2x over cosine 2x. Next, we can combine the two fractions. So in the numerator we have 1 plus sine 2x over cosine 2x. We can then use a double angle identity from the formula booklet from page 7 to rewrite sine 2x as 2 sine x cosine x, and to rewrite cosine 2x as the first identity. So we can rewrite it as cosine squared x minus sine squared x. The reason why we want to use this first identity and not the ones involving cosine or just sine is because this one can be factorized further as it is a difference of squares. This is useful because we then need to cancel out the extra sines and cosines from the top and bottom. The numerator is still quite difficult to work with, so we can notice that the 1 can actually be rewritten as the Pythagorean identity as cosine squared plus sine squared. So we can do this, and then we see a very nice pattern that the numerator is actually a sum of squares, which can be rewritten as cosine plus sine and all of that squared. As I mentioned before, the denominator can also be factorized, so we can rewrite it as cosine plus sine times cosine minus sine. One of the factors on the numerator cancel out with the cosine plus sine factor in the denominator, and we're left with what we were meant to prove, so cosine plus sine over cosine minus sine. Part C asks us to find the definite integral of secant 2x plus tan 2x in this form. As we proved in Part B, we can replace this integrand with what we proved in Part B. So instead of the secant and tan, we can write the fraction involving cosine and sine. Since we know that we need to end up with ln as the final answer, we can replace the denominator with u. So that means we make u equal to this denominator. Then we can take the derivative, so we end up with minus sine x minus cosine x dx, and then we can take out the minus out of the parentheses, and we get something very similar to the numerator. So we can use this to replace a part of our integrand and replace it with du. So this means that we can replace the numerator with du, and we also have to put a minus sign in front of the integral to maintain this value. Next, we can replace the denominator with u, since we made u equal to cosine minus sine. An important fact to note is that when you replace the integrand with u, you actually have to change the limits as well, which I actually forgot to do here. So the limits must actually be x equals 0 and x equals pi over 6. And this is important since the examiners might take off points on the exam if you do not do this. Page 12 in the formula booklet contains the standard integrals, which we can use to our advantage. Since we have this standard form of 1 over something, or 1 over x or 1 over u, we can integrate this integral and get ln of absolute value of u. And also don't forget the minus sign. And we don't write the plus c because this is a definite integral. So instead we write our limits. Next, in order to compute the integral, we can replace u with the substitution we originally used, so cosine minus sine. Then we can use the fundamental theorem of calculus and substitute pi over 6 into the x, so we get ln absolute value of cosine pi over 6 minus sine pi over 6, and minus ln cosine 0 minus sine 0. Since the form that the question asks us to write the answer in is positive, we need to flip the stuff inside of the ln, so we get 2 over square root of 3 minus 1. And to get it into the actual form that the answer needs to be in, we can then multiply the top and bottom by the conjugate of the denominator to eliminate this square root. So then the final answer would be ln of square root of 3 plus 1. So that's it for this video. Thank you for watching, and I hope I helped you answer this question.